I'm Mark Sponsler, and welcome to the Stormsurf Video Surf forecast for the week starting Sunday, December 19th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see a small fetch area generating 18-foot seas aimed south, midway between Hawaii and California, and then another broader fetch area generating 26, maybe 28-foot seas, but all effectively pushing up into the Bering Sea and of no interest to us right now. At least there is something in the Pacific to discuss. Let's get into the details. As usual, we'll start by looking at jet stream level winds in the North Pacific. The jet, of course, pushes off Japan here, with winds looking pretty good at about 70, 170 knots, something like that, but then splits majorly here on the dateline, with most energy moving into the northern branch of the jet, pushing up into the Bering Sea, and then down south into what's known as a trough, a dip in the jet stream falling south, and that's exactly what we want to see, because a jet falling south like this helps create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, turns into surf. So troughs are what it's all about in the upper atmosphere, and the upper atmosphere is what drives everything down at the surface. So that's why we spend time looking at the jet stream. So right now we have a pretty decent trough off the Pacific Northwest, being fed by, well, these pretty decent winds here, about 130 knot winds. Actually, maybe we can get the scale right. There we go. 30, 140 knots, and that gets a pretty good counterclockwise flow going there, and that, of course, is supporting 18-foot seas being generated in this area, at least for the minute. All right, let's go look into the future. Also, before we get into that, right here, this big split, between the split flow typically is where you get high pressure, strong high pressure, that does nothing for generating surf. So we don't want to really see a split jet stream. We want to see a consolidated flow like what's pushing off Japan, but we want to see that go the whole way across the Pacific. Also to note, we are in La Nina, no big surprise there, but there is this high pressure bias we've been talking about. We're going to get into that in a minute, but that high pressure bias is sitting right here over the dateline, so it's no big surprise the jet is split at the high pressure bias. In fact, the jet stream is pushing off, it hits the bias, and that's what splits it in half, and that's what's creating this high pressure, well, you'll see down at the ocean surface, and then that's pretty much what sets up the pattern for the entire North Pacific. Anyway, as we get into Monday, the trough off the Pacific North and West sort of pinches off. It's a backdoor trough. It's like inland, pushes out over the ocean. That grabs cold air here over Canada, pushes it off the coast, and then comes back onshore over California. So as we get into Monday, the trough almost completely pinches off and looks like the jet's just going to take off this way. But then as we get into Tuesday night and Wednesday, bam, this ridge builds again, starts falling south, reinvigorates this trough yet again. But notice how pinched the trough is. It's not going to really do a whole lot for generating swell, we don't think, but it will do a lot for pushing cold air down into California and precipitation over. All the precipitation, all the energy is following the jet up here, over, and then down the coast. So more of a weather maker than a surf maker. So we're into now, Thursday? And then notice yet another reinvigorating bit of energy falling south in the jet as we get into Friday. And all this energy right here over California. And we'll get into that. I'll go back and show you in just a second. And yet even more into Sunday, supposedly. We're 180 hours out. And look where the jet is now, pushing over Baja. So we'll go right back to the beginning. What we're looking for is where the jet comes in over California. They call that an atmospheric river. And what it does is it creates precipitation. Here you go, starting Tuesday morning. Notice the winds building in the jet, starting to impact northern, where is that? That's actually the San Francisco Bay Area. And it starts on Tuesday. It lifts north a little bit on Wednesday, starts falling south again on Thursday, down into central California, even southern California. Friday, more energy starts building into San Francisco. Saturday, and then even into, do we get a little bit more on Sunday? Looks like it, right in there. I mean, there's just this big sweet spot for piles of moisture. Now, this year, we were really concerned about not getting any moisture in. The only hope we said really was these backdoor fronts, and this is a classic example of one that's forecasted. Again, a forecast is not reality. It's a projection in the mind of a computer based on a whole bunch of stuff which may or may not happen. But the models have been pretty good. We've had two atmospheric river events so far in California this winter that have given us in the San Francisco Bay Area about 9 inches of precipitation, which is about 50% of what you would expect for the entire year. It's like there's nothing, it's beautiful, it's summertime, all of a sudden the clouds come in, boom, the rain starts happening, someone turns on the faucet, it dumps and pours rain for a couple days, and then it clears up, and of course you get snow in the mountains. Clears up, and then it's all over, and then it's back to summertime again. So a lot of variability from one extreme to the other, but if that's what it takes for us to get precipitation, we'll do it. We're in a drought. Every drop counts. Right now, snowpack in the Sierra, 100% of normal for this time of year, or 97%, basically speaking, in the central Sierra. So not a bad place to be. Also notice, 180 hours out, 200 knot winds. Let's see, actually, is that 1, 2, 3, 1, 2, 3. 210 knot winds forecast pushing off Japan. So if this split point, you get the sense that it's slowly creeping east. If it could get over into here, like somewhere north of Hawaii, that would really turn on the storm machine. Don't know if that's going to happen. The high pressure bias has to move. But again, we're getting way ahead of ourselves. Let's move on. Right, next up, surface level pressure, surface level winds. No big surprise. 1044 millibar high pressure right here. The split point in the jet is somewhere here, and the jet is splitting going up there and down like that. And there's a little low pressure, 1008 millibar. That's hardly even a low pressure. But a little bit of fetch, 30 knot winds, mainly driven by the high. The integration of high pressure here, creating a clockwise flow. Low pressure here, counterclockwise. The closer they get to each other, the tighter the isobars get, the stronger the winds get. 30 knot winds is not much, generating 18-foot seas. We're into Monday, sort of more the same, and then a little bit more fetch builds. But notice, this is really kind of aimed more south or even southwest, not at California. Also of note, a gale forecast here developing over the dateline. Small area, 45 knot winds, building to almost 50 knots there as we get into Tuesday morning. Quickly lifting north and out of there. Split jet stream not doing anything. Low holds off the California coast. We get into Wednesday, sort of the same pattern. New low pressure starts building over Vancouver Island, falling south, generating, what's that, 25 knot winds. Again, that's nothing really of any interest. A little bit more, 30, 35 knot winds as we get into Friday. Just mainly a weather machine completely. Low pressure again trying to develop right at the split point of the jet as we get into Saturday. Maybe this will make something. I mean, we're pretty far out in the models. Look at that. Really nothing. It lifts north. Another system starts developing off Japan. Again, it races off to the north. We're into Sunday, a week out, and all the fetch, for the most part, landlocked behind the Kuril Islands. A little bit off there, but not too much. 1040 millibar high, just locked in place. So not a great situation for real swell development, like big storms pushing over the dateline with 50 knot winds and 40-foot seas, all that kind of stuff. No, it's local wind swell pushing down the California coast. Hawaii, yeah, wind swell, little bits of spurious energy coming from these gales off the Kuril Islands, but nothing super impressive at all. Okay, what's the effect of those winds on the ocean surface? We're going back in time. We're kind of ignoring this because swell from this is Monday a week ago, has already hit and gone. But there was this little low that pushed off the Kuril Islands, produced 30-foot seas, but really we'll say 29-foot seas, and then did the same deal. Didn't even quite make it to the dateline, which is right here, then just fell apart, blew north. But that actually produced a swell. We saw waves double and a half overhead and on Sunset Beach in Hawaii 2 days ago. That swell has hit Northern California. Nothing huge, but top spots. Waves were head high, a foot overhead, lined up, 16, 17-second period. Something to ride, bit of a wait between sets, but there were waves. Those south winds were starting to build. Anyway, so we're going back. We're still back last Thursday. Days ago, we're just sort of looking at another little tiny system here developed on the dateline. We were thinking this was going to make something for Hawaii. Still think it should, but there's also supposed to be some wind swell hitting about the same time on the Hawaiian Islands. So probably more wind swell than actual real, great surf. Now looking forward, all right, we know we have our little fetch and 18-foot seas off the California coast, mainly aimed south. Little spurious bits of energy maybe developing as we get into Tuesday. Also notice this fetch here over the dateline. Again, probably sending little bits of energy towards Hawaii and the U.S. West Coast. Probably pretty negligible. More fetch as we get into Wednesday and Thursday. What is this, like 14 or 15-foot seas? And all very north angled. Doubtful any of that's going to get into Southern California. We continue on Friday. More fetch, aimed better at California. Pretty raw energy, 18, 19, maybe 20-foot seas, something like that. Sort of keeping an eye on what's going on here as we get into Saturday on the dateline. Again, 20-foot seas, maybe some 12 or 13-second period swell for Hawaii. And then Sunday, a week out, another low, pushing off the Kuril Islands, 36-foot seas or something like that, and then we're done. So the real obvious call is no immediate signs of, what we call significant class gale development, no major seas. Wind swell, basically local north wind swell for California this week. Not good. Hawaii, not faring much better. Rideable waves, but nothing more. And we're just waiting for something to happen with that split in the jet, for energy to push the split further off to the east. The good news is it looks like weather is setting up for California. A quick look at the wind situation for California. Here is low pressure, rotates counterclockwise. South winds, light, but 5-10 knots, pushing up along the North California coast. Stronger upper at Cape Mendocino, weaker the further south to Point Conception you get. And that's pretty much the pattern for the rest of the week. Monday, south winds, you can see it down to at least, Monterey Bay, if not further south. Low pressure continuing, 20-knot south winds off the Bay Area as we get into Tuesday. Wednesday, south winds back off a little bit, but here comes the next wave of low pressure. They're not even like closed isobars lows, really. It's just generic low pressure, generic high pressure, just setting this flow up, pushing down the coast. But it's going to give us precipitation. There's some legitimate fetch. And there's a closed isobar low, a 992 low? We consider like real low pressure, like a 968 millibar low. So this isn't even close. But again, this is south winds or west winds, at least for the California coast. Friday, there's the more west-southwest winds Saturday. And then maybe a little bit more northerly on Sunday. But still low pressure near shore. Let's go take a look at the precipitation models. Okay, the blues precipitation, yellows, heavy precipitation, but then you get high elevations where you see the white and the gray wrapped around it. That's snow. California right here, Bay Area there, Point Conception there, Southern California down there. We're just mainly looking at what's going on here in terms of precip. Cape Mendocino on Monday, maybe a little bit off the Central California coast, but that sort of disappears. Notice the low winding up off the coast Monday night into Tuesday. A legitimate front with rain forecast off the California coast and impacting it. Tuesday afternoon, finally Wednesday, precip moves into the Bay Area and points north of there. A little bit of snow in Tahoe by Tuesday night. That continues into Wednesday, and then here we go. More precip, and you notice this is pretty heavy snow building, actually real heavy snow, building over the entire Sierra on Thursday. Look at that. On Thursday night, very heavy. Friday, more the same, another pulse, not as heavy. Saturday, more precip pushing down the Sierra, rain everywhere else. Sunday, more snow, and it looks like, another wave getting ready to set up and push south on Monday. Now here's just mainly the snow models where we're getting there. Tahoe is right in there, Mammoth down in that area, San Francisco Bay Area, Point Conception, Southern California there. Looking around the microphone here. Here we go. All right, push this into motion. You see the main event starts about 4 p.m. on Tuesday into North California and Central California a little bit later that evening. Snow down the entire ridge of the Sierra as you get Wednesday, Thursday. That's a lot of snow. 24 inches in 6 hours. If you believe that, that's probably a little bit on the high side. Friday, Saturday, we're not, there we go. Saturday. This is a 10-day model. Sunday. And then on Monday, it looks like Monday night, things clear out. And then after that, maybe a little bit more even. 240 hours out, we'll see. Don't believe a model even a week out, much less 10 days out. But you get the general idea. Let's go look at some accumulation potential. Squaw Valley here, literally off the charts. We'll click it. Let's go see what we can really get. Let's see if we can get that all centered up there for you. All right, here's the actual numbers. Supposedly 157 inches of accumulation. That seems way over the top, but that is, at least it gives you kind of a sense of where we're heading towards, a fair amount. Now, the other thing is, look at the freezing levels. This is the base of Squaw here at 6,200 feet. The top, about 9,000 feet. That'd be up there at the top of Siberia and the top of Granite Chief Chair. If you hike the peak, the white is the freeze line, so today in the 8,000 foot range. Tomorrow, same deal, about 8,000 feet. But then as you get into Tuesday, temperature falling dramatically as you move through the day. The freeze level down to 5,000 feet, bouncing back a little bit on, Wednesday into early Thursday, and then down and down we go with freezing levels the whole way down to the surface, supposedly, in multiple, in 2 different spots. That's pretty cold. You get a lot of precip out of that. Wind, not so bad for an atmospheric river event. And those big events that we had back, when was that, 2016 or somewhere in there? I mean, it was not uncommon to see 200-knot winds. So 60, and even if this is 70 and a little bit underestimated, gusts maybe in the 90-knot range, something like that. But still, not horribly bad. Good for not blowing the snowpack, flatten it down to nothing, but still probably pretty windy up high, just given that it's an atmospheric river event. We'll do the same deal here. Mammoth, you can see lots of snow. Click in, zoom in. Let me get it centered here so you can see what's going on. 105 inches. Okay, that's not too bad. But Mammoth gets the benefit of being even higher. Here's the base of Mammoth at 8,000 feet, maybe 8,200 feet, something like that. Here's the summit, about 11,000 feet. You can see even as of today, it's almost, at the heat of the day, it's frozen almost to the base. And as we get into Tuesday, it's all below base from there on. You notice there's not a whole lot of difference between the Squaw, Olympic Valley versus Mammoth in terms of freeze levels, even though they are further south. The upper atmosphere, not as dynamic as down at the surface. Things are much more stable. Much broader brush strokes can be used when trying to forecast. And then a quick diversion here real quick. We got a question. Talk to us about the swell window for Central America. Okay, so we're going to do that just real quick. And I'm just picking in general. Punta Guiones. I don't know how to say that correctly, but that's close enough. And we're using Google Earth here Pro. We're going to show you. So here, and this is the Great Circle Path. We're just centering it right there. And it goes north. We'll say cutting really close right off of Mexico right there. And what is that? 305 degrees. Okay, that's okay. Let's go a little bit. So we're just doing this. Oh, but then that's not the case because we have land up here. So let's go. You keep extending out. This is the Great Circle Path. It's not a straight line. It actually bends, and you'll see in a minute. So there is Mexico, and we're just eyeballing this roughly 297 degrees. All right, now let's zoom further out, and we'll sort of rotate, the other way. There we go. And so 297 degrees, and we'll continue this out. We're just going to go way out here. We'll take it on over, whoop, other way. Sorry, there we go. Yeah, you get to see this real time, the ugly truth of how some of this goes on. All right, and there you go. There, and let's make sure this is at 297 degrees. We're a little bit high. There, roughly 297 degrees. All right, so what is this? You see this line right here? This is like Baja. We're at, what is that? Oh, you can't see it on the screen, but that is what, the 20 degree. Oh, I have to pull the whole thing up so you can get it. Oh, and I can't get it in the frame because I'm in the way. There you go. Okay, so we'll pull this out right there. And if you look down here, we'll do this right in a second. There you go. So it's 29, okay, 29 degrees north. And so any storm that's north of this line will generate swell. It'll impact the whole way down here, but the swell will hit that piece of land there, get cut off, never make it into Central America. So the point being, any storm that's north of 29 north is not going to generate swell for Central America. And the reality is almost all the storms in the Northern Hemisphere, and let's see if we can go down just a little bit, get this out of the way. Here we go. Go down, oops, other way, boom, 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 boom. There you go. Pull that out of the way. The main storm track is like right up in here. Maybe you get some that are down about 30, and once in a rare blue moon, you'll get some that'll fall into this swell window relative to Hawaii. So that last gale that sort of targeted Hawaii, but all the fetch was aimed due south. The fetch has to be aimed up the Great Circle Path or down the Great Circle Path to Central America to actually generate swell. So you see, it's a pretty tall order to get swell into Central America. But anyway, that's our tidbit for today. Let's move on. Let's go take a look at the long-term outlook. What's going on with the Madden Julian Oscillation, that periodic weather oscillation that goes around the planet on the equator, and of course, El Nino or La Nina. As usual, we start by looking at winds on the equator. All right, the MJO, this periodic weather oscillation, will do, let's see, get in the frame, there we go. There is an active phase and an inactive phase to the MJO. They rotate around the planet, one on one side, one on the other. The active phase is the one we want. What it does is it imparts energy. It's a low pressure system. It imparts energy to the jet stream. And when the jet stream's stronger, as you saw, it helps generate waves, generates troughs. And you want those troughs, of course, over the Pacific. When the active phase of the MJO, one of the two phases of the MJO, moves over the West Pacific. So this is the West Pacific here. This is the East Pacific here. This is the equator. This is the dateline. When the active phase moves over here, typically it reduces trade winds, helps impart energy to the jet stream, which generates storms. Also, when it reverses trade winds in the West Pacific, that in turn can take warm water that's typically here, start pushing it east in the form of a Kelvin wave, a ball of warm water that travels under the equator the whole way across the Pacific, then eventually erupts near Ecuador. And when it does, it brings an upwelling of warm water to the ocean's surface. And that, if you get successive active phases and successive Kelvin waves, can kick off a El Nino. And we all know that El Nino is great for surf in the Northern Hemisphere in winter months. All right, so looking at data from the TAO buoy rays, series of buoys strung across the equator, we're just looking at the arrows here. This is 5-day average winds. You see winds pretty strong out of the east. Over the East Pacific, pretty stronger still over the Central Pacific, and pretty strong in the West Pacific, the Kelvin wave generation area, because when the active phase is over here, this is where Kelvin waves get generated, not over here in the East and Central, but in the West Pacific. But it's not the actual wind speeds, it's the anomalies, the differences from normal for this time of year. We're seeing that, yeah, the winds are pretty strong right here, but you're looking at these arrows, they're pretty weak, they're not really going anywhere, so that's pretty much normal for this time of year. And yeah, winds are strong over the Central Pacific, but not that strong. The arrows weakly out of the east. Kelvin wave generation area, unfortunately, still pretty strong out of the west, out of the east. We want to see westerly anomalies. We want to see the arrows reverse direction. That would be a clear indication of the active phase of the MJO. We're not seeing it at the moment. Let's go look at the 1-week forecast. All right, so here we go. Whole planet on one chart. So let's get oriented. The date line runs right up the middle, right here. Okay. Time here, going back to November 19th to current. Here's today's current date. So the blues represent easterly anomalies. Winds stronger out of the east than normal. Reds stronger out of the west than normal. Okay. This is what we want to see. This is the active phase of the MJO. And typically, you want to see it a line going the whole way across the chart like this. But it's been blocked, this blocking pattern. Same with the easterly winds, locked in place. There's the date line, right over the date line. They've been there since November, since way before then. Okay, this is that La Nina blocking pattern, the high pressure ridge that's just locked over the date line. This is how that manifests on this chart. You see easterly anomalies. We actually had, this is the active phase of the MJO trying to push across the Pacific here in December. It kind of stalled. Then you get the sense that it sneaks through here in the next, this is what, in the next day or two, and tries to make it across the Pacific. And that's really what this is. Active phase aligned this way, going like this. But the La Nina high pressure bias, whatever you want to call it, is still controlling the date line for the moment. Next up, we're looking at outgoing long wave radiation, another component of the active and inactive phase of the MJO. We said the active phase, the good phase of the MJO, not to be confused with the evil phase, the inactive phase. The active phase is like a low pressure system. Okay, and low pressure generates cloud and precipitation. All right, so the outgoing long wave radiation is fancy words for cloud cover. The blues, negative anomalies. Less sunlight reflecting off the ocean surface means more clouds, and this is where the active phase is. All right, so EQ is the equator right there. Okay, South America, Central America, Hawaii, Philippines, New Guinea, Australia. Date line right there. Kelvin wave generation area roughly in this area right here with the active phase of the MJO over there. Hey, that's pretty good. This per the statistic model. And I look out 5 days, 10 days, 15 days, 2 weeks from now, active phase still hanging over the date line. That's pretty good news. And then we look at the dynamic model, and it's saying almost the same thing. If anything, here we'll go. There's what the statistic model says for the active phase on the date line right there. The dynamic model has the active phase even stronger on the date line a week from now, or 2 weeks from now. Okay, so what does that mean? We're thinking that the longer the active phase stays in place and the longer it slowly moves off to the east, that split point in the jet is right on the date line right now, right there. So the jet's coming off like here, and then it hits where the active phase ends and it splits, and then high pressure is over here. Okay, the longer this slowly moves off to the east, it'll drag the split point with it. At least that's our thought for the moment. Next up, phase diagrams. Another way at looking at the active phase of the MJO. For the statistic model and clearly the dynamic model, phase diagram, for whatever reason, is just hosed today, so we're going to ignore it. All we have is the statistic model. But anyway, okay, the MJO moves west-east from the Indian Ocean over the Maritime Continent to the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is, so it's in the Western Pacific. Hey, that's great news. That's exactly where we want it. The further the dot is away from this circle, the stronger it is. So we'll say weak to modest strength active phase. And then this is the forecast, 15 dots for 15 days from now. And basically the active phase moving to somewhere over Africa or maybe even into the Indian Ocean 2 weeks from now. Now, the dynamic model, you can't see it here, but it has basically the active phase just noodling around somewhere in the west to east Pacific for the next 2 weeks. That's more favorable. That's what we want. We want to see the outcome from the dynamic model. The upper level model, all right, propensity for precipitation. The greens favor precipitation, the yellows more like dry air. And there's 8 different panels going out 40 days. I know. Don't believe a model a week out, we're going out 40 days. Well, sometimes it's fun just to look and to dream, right? All right, South America there, Central America, right there was at the Galapagos. 0 is the equator. The date line roughly there. There's New Guinea, Australia, the Philippines, Kelvin wave generation area right here. The greens area is favorable for precipitation. So this is our active phase over the Pacific right now. You can see it little bit at a time, slowly moving east and out of the Pacific as we get into mid-January. At the same time, you see the inactive phase, dry air here, moving over the maritime continent into the Pacific somewhere around first week of January, and it making its trek across the Pacific into the end of January. At that time, January 23rd, wet air and the next active phase supposedly moving into the Pacific. So this suggests that pretty much as we get couple, let's say a week after New Year's, things are going to shut down. Whatever we're going to get, and then it's over for a month until the next active phase shows up, at least according to this model. All right, so let's go out a month. This is the CFS model, another pretty good model. This paints the picture a little bit differently. 180, whole planet on one chart. This is the date line running right up the middle. The West Pacific starts about 135 east, so right about there, and goes to about 170 west, so the West Pacific, roughly right in there, right? The solid contour like here is the active phase of the MJO. Reds and oranges, whatever you want to call those colors, those are westerly anomalies typically associated with the active phase of the MJO. The blues, easterly anomalies, the enhanced trade winds, the dotted contour, the inactive phase of the MJO. So a weak active phase of the MJO back in late September, early October, something like that. Then the inactive phase set up from late October the whole way through November. And then here's our current stronger active phase with stronger westerly anomalies working its way across the Pacific into the central Pacific. And it's expected, now notice this, you get westerly anomalies. They break up here for just a couple of days. And by tomorrow, what's the 19th? Oh, that's today. So maybe by tomorrow, by Monday, westerly anomalies start building again over the West Pacific and continue into about the first week in January. Then they start fading off, and then you get this dotted contour here. The suggestions that the inactive phase of the MJO is coming behind that. So far, all the models in pretty good agreement. And if you're going to dream big or go home, the 3-month CFS model, all right? Past performance down here, August, September, October, November, December. Looking forward, January, February, March, all right? Get ourselves aligned here. Date line running right up the middle, 180 west. Okay, blues are easterly anomalies, inactive phase. Yellows, westerly anomalies, the active phase. And so there's our current active phase. In fact, if any, you can see it actually migrating across the Pacific this way, or the forecast at least. And you can see the last inactive phase doing its thing with its easterly anomalies moving across the Pacific. The good news here is the active phase and the inactive phase are actually present and somewhat cohesive. That in the past, for the past year, it's been nothing but just steady inactive phase. So now there is some sense that the MJO is trying to come back. We'll overlay it. All right. Solid contour is the active phase. Here we go. Our current active phase. Looks like we're just getting going. We have, well, the Kelvin wave generation area ends right about here. So through about January 4th or 5th, something like that, with westerly anomalies, again, in the Kelvin wave generation area. So maybe feeding energy into the jet stream, maybe helping us a little bit. And then here comes the dotted contour, the inactive phase, setting up, well, as of even in a day or two, starting to build in the West Pacific. But notice, westerly anomalies pretty much holding in some degree until you get into about January 12th, something like that. And then it's nothing but easterly anomalies into about the first week in February. Then we come with another active phase and westerly anomalies after that. So the good news here, inactive, active, inactive, active, inactive, active. At least there's a pattern starting to build of the phases. At least the active phase is here. It's not very strong, but it is here. All right, the low pass filter, the last little sort of magic sauce in what's really going on. I know there's a lot going on here, but what you want to look at, and I'll turn it on and off so you can see here, these two things, the dark heavy contour, which is a low pressure bias, that's what we want in the Pacific, and this dotted contour, the high pressure bias, what we don't want in the Pacific. But remember, here's the date line. Here's the high pressure bias. This is like just like fairy dust kind of, it's there, but you can't really see it, but we know it's there. But then you look at this perpetual down at the surface, high pressure, just locked over the date line in lockstep, and it's all driven by this high pressure bias, or vice versa. This high pressure bias is a sign of the perpetual high pressure that's been on the date line, and the expectation is that will continue. But notice, it's slowly moving from actually a hair bit west of the date line as you get 3 months out to a point actually just off the California coast. And the low pressure bias here starts moving right now barely in the Kelvin wave generation area to a point, about halfway through it, and even more at the end of the model run. And this is exactly what you want to see, sort of the beginnings of a return to normal in the Pacific as we get into the spring. Not normal, but maybe a start in the underlying fundamentals supporting the end of La Nina. La Nina is this high pressure bias, this high pressure pattern just locking down the Pacific while low pressure holds over the Indian Ocean. We want these two to flip. They just don't flip. What happens is the high pressure bias moves east and out, and the low pressure bias moves east into the Pacific and then takes up shop there. All right, subsurface temperatures. What's going on down in the Pacific? This is the West Pacific here. This is the East Pacific here. We're just looking at temperatures. This is in centigrade, all right? And we're trying to get a balance of where the warmer temperatures are and cooler temperatures are. During El Nino, warmer temperatures shift over the East Pacific. During La Nina, they stay in the West Pacific. So we look at this week to week and see if there's any eastward shift in the temperature gradient. 29 degrees centigrade isotherm. This is actually bigger than it was a week or two ago, suggesting, hey, a little bit of warm water trying to build. The 28 degree isotherm right at the date line, it's held there, but it seems to actually be getting a little bit more volume behind it. The 24 degree isotherm, locked solid at 125 west. No change there. Much less warm water in the east, more of it in the west. But it's not the actual temperatures, it's the anomalies, differences from normal for this time of year. We now have, it's been just 2 degrees centigrade temperatures balled up in the West Pacific, now building to 3 degrees. So warming here, the actual line, this wall has been locked. Where is that? 165 west right there. That's steady. That's where it's been for a long time. 2 degree below normal temperatures in the East Pacific, driven by upwelling, stronger than normal trades here, causing upwelling, cool water, and it moves to the surface, creates a cool pool, which sets up high pressure over top of that, which feeds the high pressure bias, which is the hallmark of La Nina. So no real change this week in this chart. Now, the higher res version model, looking at this data, pretty much the same general picture, but warmer temperatures building much stronger in the west. We know we have the active phase here. We know it's creating some west anomalies. That might be pumping some warm water into this pool. The question is, can this warm pool make any eastward momentum? This cool pool in the East Pacific is pretty much locked in place. We don't expect it to change immediately, but it is slowly getting weaker over time, and we'll see that in a minute. Sea level anomalies. All right, so this is, let's get oriented here. South America, I know it doesn't look like it. Peru right there. Central America, Yucatan, Baja, California, Hawaii right in there. This is the equator. This is the date line. New Guinea there, Australia. These are not temperatures. These are not wave heights. They are the height of the sphere of the ocean. Jason 3 satellite collects this data, beams it up, strip out all the waves, the wind waves, the tides, and is the sphere higher or lower than normal? These are minus 15 centimeters here, minus 10 centimeters here, minus 5 centimeters off of, well, there's Galapagos, Ecuador. So the ocean is lower than normal here. And what's that mean? Well, cool water at depth, whoops, let's get that in the frame. contracts. When it contracts, it creates a divot on the ocean surface. Warm water at depth expands. When it expands, it creates a bump on the ocean surface. So you see we have a bump here, plus 15, plus 20 centimeters above normal. Warm water in the West Pacific, all balled up there. Cold water in the East Pacific, all balled up there with a brick wall between them. And the MJO, not strong, the active phase of the MJO, not strong enough to push cleanly across the Pacific and sweep that warm water into the east to help level out the ocean surface. Now that's going to happen at some point, but probably not for a few months still. And I like this chart, upper ocean heat anomalies. This really paints the picture quite well. West Pacific here, East Pacific here. The reds, warmer than normal temperatures. The blues, colder than normal temperatures. Last January, La Nina, cold temperatures in the East Pacific. Last March, active phase of the MJO tapped this warm pool, created a Kelvin wave, pushed warm water across the Pacific. Once, a second Kelvin wave, second active phase. Third active phase in the June, July, and it all just petered out. The warm pool was tapped out, and that was the end of it. Here comes the second phase of La Nina. Stronger, more cold water than even the year before it. Okay, but notice, cool water quickly retreating, losing volume, losing area. Now there's still these, I'll call this area here, and this little ball here is a little bit concerning. We hope it's not like another pulse of La Nina, though it could be. But also, here's our building warm pool off here. For now, basically, La Nina in control. The peak of it happened in mid-October. It's fading, but not completely out. Maybe it's a little second, or actually maybe a third pulse developing right now, but not very strong. Surface temperature anomalies, differences from normal in the sea surface temperature as compared to years past. Chile right there, Ecuador, South America, Central America, Baja, California, Hawaii right there, and then the equator roughly here. You see the blues, colder than normal temperatures, well in control over the equator. Little bits of warming in pockets here, nothing significant. A little pixels of warming trying to get a foot here in at Chile, but still a very cold pocket right here. That big reservoir of cold water at depth, we believe, is erupting to the surface. It's a cold water Kelvin wave. This is the peak of the cooling right here, right behind the Galapagos. The trade's blowing from the east the whole way across here, taking that cold water, just dragging it across the Pacific. Cold water on the equator sets up high pressure above it. High pressure above it basically acts as a block to the storm door, and then storms, sends them all north into the Bering Sea. So this is really the typical La Nina pattern. Let's see what the trend is. Sea surface temperature trends for the past 7 days. We see oranges warming along Peru, along Chile and Peru, and off of Ecuador, and a bit out almost to a point, to 140 west. Little bit of cooling, but not too bad. It seems like the active phase of the MJO is having the desired effect of stomping on the trade winds, therefore allowing warming to occur. When you get warming, if it's significant enough, then you can actually start getting precipitation and return to a more normal pattern. But 7 days of warming is not a trend. It is just an interesting tidbit. Here's the backed off view. You see it quite plainly here. Cold water off of South and Central America the whole way out past the date line, just locked in place. You think that's going to feed a giant ball of high pressure right around in here? Well, it is. We have our little backdoor fronts pushing down the California coast, giving us precipitation. But that is more of a gift than anything. We'll take it, but it's sort of a freak event. We said that might happen this year because we thought the high pressure bias had moved further to the west, more over here, and that appears to be what's going on for the minute. So every bit is good. This next atmospheric river event, we're hoping it just dumps on us completely, get us to at least 75% of normal precipitation. If we got another 5 inches of rain in Northern California, which seems entirely possible over the next week, then we would not be in a great place, but we'd be approaching normal. That won't make up for last year's deficit, but at least we'd be in a better place going into the summer than if we didn't have any precip at all. But right now, this still looks clearly like a La Nina pattern. Temperature trend in the Nino 1.2 region, the area right there along Ecuador, the Galapagos, and Peru. Temperatures slowly dropping down. Almost, 1.933 degrees below normal, almost 2 degrees below normal. Now, this is not an official, like, El Nino area. They monitor it. It's pretty noisy, but clearly things are colder along the Peruvian and Ecuador coast, a classic sign of La Nina. The official El Nino region is the area on the equator from a point south of California out to about the dateline. Temperatures pretty stable at the moment, 0.911 degrees below normal. La Nina starts at a half a degree below normal, so we've been below that threshold since at least the end of September. Clearly still in La Nina. Not as the models are suggesting colder temperatures, but right now, just keep this in your mind, 0.9 of a degree below normal. All right, what's going on in the atmosphere above the ocean? We know we have colder than normal temperatures on the equator. That's not a good thing. We suspect that's supporting high pressure, but do we have some empirical evidence of that other than, well, there aren't a lot of storms and where's the surf and all that kind of stuff? Give me some hard scientific data. All right, Southern Oscillation Index tries to do that. Measures the differences in pressure between Darwin, Australia, roughly in the Indian Ocean, and Tahiti, which is in the Pacific. When the pressure in Tahiti is lower than Darwin, the index goes negative, like today. Now, they're not absolute. It's a relative sort of sliding scale. But today, minus 2.13, just barely below normal. But you look back for the past month, all these values right here are, for the most part, all positive. The 30-day average, just a straight 30-day average of all these numbers, tells you, gives you sort of, takes the noise out of it. The value today, 12.18. Okay, that's pretty high, positive, suggesting high pressure in the Pacific. And we went back a month ago. We were only at +6, and now we're at double that. Last year at the peak of La Nina, I think it was in January, this got to +19. We'll see if we get there. The 90-day average it out even over a longer period of time. Today, +9.92. And it's been, look at that, pretty much rock solid for the past 30 days. Last year, this got up to +15, I think. Right now, we're only at 9. We're still not where we were last year. So is this La Nina going to be a little bit weaker than last year? Well, we don't know. But symptom-wise, it appears not. 30-day moving SOI, all right? The 30-day average graphed out. You can see January of 2019, we were negative, sort of a weak El Nino. Last year, here was our peak in January at, this says +21. Other data says +19. Either way, you get the idea. So where are we equivalent-wise? Well, right now, we're about a week out from that same spot as last year, and that's about where we were. We were on quite a big tear of the inactive phase of the MJO last December. That's not the case right now. In fact, we're sinking deeper into the active phase right now. So are we going to get as high as where we were last year? I suspect probably not. Again, giving us the sense that, at least from the numbers, this La Nina, this year's La Nina, not as strong as last year's, though atmospheric-wise, one could debate that. And finally, the forecast for the official El Nino region, the Nino 3.4 sea surface temperature anomaly forecast. All right, so today, where are we? We're December, mid-December or later, right about here on the curve, something like that. And these lines are mid-January, not the beginning of January. So one of our readers indicated that, and that was a good tidbit of info. So according to the model, we're about 1.1 degrees below normal. Remember when we looked at the actual temperatures, we were about 1 degree or 0.97 below normal. So this may be overstating a little. This model is suggesting temperatures going down to 1.35 below normal, and then rebuilding from there. Now, this is the raw data. The corrected version is probably closer. This is suggesting maybe minus 1.25 degrees below normal, 1.3, something like that. So a little bit colder still on the equator till that big cool pool discharges. And then after that, it's all moving into a better place. So for right now, swell-wise, wind swell for California, North and Central California. Maybe some small ground swell mixed in. A couple of small little low gales, I guess I'd call them, off of Japan might produce some a little bit more meaningful swell for the Hawaiian Islands. But size-wise, not a whole lot expected. Take what you can get. We said this earlier. We're in La Nina. You make the most of whatever you can get. But this year is really starting to top what we'd say we've seen before. We've expected on a 1 to 10 scale, 10 being the best, this year it'd be about a 3 on a 1 to 10 scale. Last week, I think we talked about knocking that down to a 1.5. I think we're going to do that because there's only one more active phase of the MJO after this in this winter. That's in February. And that even doesn't look that strong. I mean, by then, the La Nina will be well set up in the atmosphere. Just grovel for anything you can get is pretty much the story for surf for this winter. Make the most of it, and right now is as good as any chance. Wind swell is what we have for the next week. The good news is piles of precipitation. Skiing. If skiing's your thing, well, and you can afford to pay the blackout rates for lift tickets during the holiday and that sort of thing, good time to go. There's going to be a major dump happening here in the next week. You know, maybe not the 10 feet of snow the models are projecting, but even another 6 or 7 feet, that would be good. That would get us into a great place moving forward. And certainly, it seems snow is in the forecast. But do not travel up there in a blizzard, and it is going to be blizzard conditions. I know people love to go up in the snow for Christmas, but be safe. It's not worth dying for or getting maimed or anything like that. There will be other days to ski. All right, and then beyond that, well, the good news is it looks like La Nina is, if we're not at the peak of it, we're probably going to be there in a week or two. And after that, then we're moving towards the demise of La Nina, we think. We're hoping. No guarantees, but we think it's pretty much going to peter out. And after that, a return to normal come next fall, probably. Something like that. All right, so that's the video for this week. If you liked it, there we go. Give us a thumbs up. If you haven't subscribed, please subscribe. You get automatic notifications when we post the video. And if not, you go to stormsurf.com. All this data is coming from there. And you can, then we post the link to the video at the top of every page of the site. You can view the video there. We do it every Sundays in the evenings. Next Sunday, it's Christmas. We're not going to be doing a video. Maybe if we're bored and we have some extra time, a couple days after that, we'll post some. But if not, we might just take a week off and enjoy the holidays. Same to you all. Happy holidays. Merry Christmas. Happy New Year. Be safe. Get some snow. Get some waves. Go have a good time. And the hope is that much better things are coming next year. All right. Thank you. We'll do this in 2 weeks. See you then. Have a great holiday.